Alright, so here we have number 5 in the energy review, and it says write the equation for efficiency. Well, we know that efficiency, wow, that's big. Efficiency is equal to our work out, our WOUT, over our work in, our WIN, times 100 to get our percentage. So the work in, or WIN, is energy at the beginning, and our work out, the energy we have at the end. Okay. So which force is doing no work, some of the work, and all of the work? Okay, so we have a box with force A being applied straight down, force B being applied at an angle, and force C being applied straight on. So which force is doing no work? Right, that would be A, because A is just, it's being applied straight down, and work is a force times a distance, and if it's being pushed down, that box isn't going anywhere. So A has no work. Which one is doing some of the work? Well, if you push at an angle like B, the box is going to go slightly, it's going to start moving to the left, but not as much as whenever you push it straight on, like when the force is being applied at C. So what's doing some of the work? The force at B. And which is doing all of the work? The force at C. Alright, here we're going into some chemistry stuff for TurboTax. What are the oxidation numbers for lithium, B, and arsenic, and all of these other chemicals? Okay, so go to our periodic table. Lithium, Li. Alright, that is in the first column, so it has a +1 oxidation. 1, 2, 3, 4, -3, 2, 1. Alright, so lithium is +1. Keep opening the wrong thing. Alright, boron is 1, 2, 3. So it's +3. Alright, now arsenic. Right here we have arsenic, so 1, 2, 3, 4, -3, 2, 1. So arsenic is -3. Alright, we have xenon, which is a noble gas, so we go 1, 2, 3, 4, -3, 2, 1, and then we have xenon. So the noble gases actually don't have any oxidation number. Na. Alright, back to our periodic table. Sr is strontium, and it's in the second column, so it's going to have 1, 2, +2. And then iodine is over here, so we go 1, 2, 3, 4, -3, 2, -1. So it is -1. Right, these oxidation numbers are telling us how many electrons these elements are gaining or losing. So since this has a positive charge, it has lost an electron. Since electrons have a negative charge, if you lose something that's negative, you're going to be more positive. So lithium has lost 1, boron has lost 3, arsenic has actually gained 3 electrons, xenon hasn't gained or lost any, strontium has lost 2, and iodine has gained 1. Okay? Alright, so how many valence electrons does lithium have? Well, we just count over 1, 2, skip transition metals, 3, 4, 5, 6, 7, 8. And for this right side, the trick, you can actually just take the 1 off of each of these columns. So 13 has 3, 14 has 4, 15 has 5, column 16 has 6, and so on and so forth. So lithium has 1 valence electron. Alright, boron has 1, 2, 3. Arsenic, 1, 2, 3, 4, 5. Xenon, we have to count all the way over. 1, 2, 3, 4, 5, 6, 7, 8. So xenon has 8. Alright, then we have strontium, which is in the second column, so it has 2 valence electrons. Fix this 8 a little bit. Alright, and then iodine. Iodine's over here, so it's in column 17, so it has 7. We just take the 1 off, and it has 7 valence electrons. Alright, so the next part wants us to make ionic bonds for magnesium and oxygen. Well, if we look at magnesium, which is over here, it has +2. So we can write Mg, and it's +2. So it is giving up 2 electrons. Let's take a look at oxygen. Oxygen has a 1, 2, 3, 4, -3, -2 charge. So we get back over here. Oxygen has -2, so it is taking up 2 electrons. Okay, so how many magnesiums do you have to have for each oxygen? You only have to have 1, because they both have this one's gaining, or losing 2, this one's gaining 2, we can just say it's MgO. Alright, and then for the next one, we have beryllium and iodine. So if we look up beryllium, it has +2. See, Be. Be has +2. So it is giving up 2 electrons. Iodine is over here. It is losing 1, or it's gaining 1. It has a -1 charge. So we have iodine, -1. So it can only take up 1. So how many iodines do you have to have in order to bond with the beryllium? Well, you have to have 2 iodines. Alright, so you end up with BeI2. Alright, blank is how we add or subtract energy from a system. Well, we know that is work. Alright, adding energy is positive work. Subtracting energy is negative work. And energy is stored work. So if you have potential energy at the top of a hill, even if you don't have a force over distance, you have stored work. So for instance, if you were to try to figure out efficiency and your work in happened to be a potential energy, that's fine. At that point, your work is the stored energy. Okay?